All right, I want to talk about body fossils of dinosaurs from Western Australia. I've got lots of slides here, so I better be quick. You're familiar with the Broome Sandstone Trackways, dinosaur trackways, which is one of the most significant trackways anywhere in the world. Here we can see some sauropods that have been trampling the area. And this is a very stark contrast to the record of body fossils from dinosaurs from the Mesozoic. So why do we have so few dinosaur bones? And I'll go through them and update the, oops, just change the concept. Part of the reason is the outcrops. This is from the Dinosaur Provincial Park in Alberta, where you have beautiful clean outcrops, whereas in most places in Western Australia, the Cretaceous outcrops are very small. Now the big issue is weathering. Even at a classic dinosaur site like Dinosaur Cove in Victoria, where you have lots of dinosaurs right up where the sea cliffs are. If you just go inland about 100 meters, the rocks will be weathered white and you find nothing. So weathering is a big problem. If we go through the dinosaur bones one by one, it's very sensitive. In 1967, there was 4 Scotch College students, year 12, that found a bone at the Bringo railway cutting 20 kilometers east of Geraldton, which is Middle Jurassic in the Coolarura Sandstone. And it was later described by John Long and Ralph Molnar. And they named it Ozraptor, which is the only dinosaur ever named from Western Australia. And the identity of this bone has been debated. It's part of a tibia, and when you have very little material, there's always going to be a debate on what it is. The current consensus is that it might be a very primitive representative of the abelisaurs. Contourus is one of these classic abelisaurs. They came to dominate Gondwana, the dinosaurian sort of predator fauna in the late Cretaceous. They're very tiny arms. So maybe it's an early form of abelisaur. It's a bit hard to tell. The other bone was found about 8 years later in the mid-1970s by a group of geology students from UWA who found a sauropod tail vertebra in the same deposits. So those are the only Jurassic dinosaur body fossils that we have currently recognized from Western Australia. Then we have, if we go up to the Cretaceous, in 1992, I think, there was a student, again from UWA, who found a toe bone in the Mokup green sand up in Gingin. Very well preserved toe bone. The age of that, the green sand, is probably the early part of the late Cretaceous. I've looked at sharks and compared them to well-dated deposits in Calvarian. I think it's pretty close to the Albion-Cenomanian boundary. And just to compare this toe bone with Australovenator, which is the only well-known theropod from Australia, they are, interestingly enough, they're very similar in size. There's the Gingin bone, there's the foot, one of the toe bones of Australovenator. So very similar in size, very similar in age as well. And we know that these, the whole group to which Australovenator belonged to were one of the dominant dinosaurs in Australia in the mid-Cretaceous. It is possible that it is from an Australovenator, or I think they call them the Megaraptors as well. And here's a artist's reconstruction of Australovenator. They had very large claws on their hands. So initially, when this group was described from South America, Argentina, they believed that the giant claws on the hand actually was on the foot, so they thought they were raptor dinosaurs, but that turned out not to be the case. Then we have the fourth bone, which was collected, I believe, by George Kendrick in the Miriam, which is a Maastrichtian deposit, so you're as high up in the Cretaceous as you can get. And I know John, I think John had sent either the bone or images to Ralph Molnar, and together they suspected it could be a theropod humerus. And because part of their argument was that it was solid. No, that it was solid. It was not solid. It was hollow. That's one of the characteristics of theropod bones. So I had a closer look at it, and this area here was actually covered by sand grains. So when I scraped it away, I realized that it isn't hollow. This is more degraded bone. And when you compare that bone to more likely, shall we say, more likely vertebrates to find in a marine deposit, like a turtle, I strongly suspect that we might actually be dealing with a turtle. This is a turtle scapula. You can see if this part here, if you look at here, it's actually been broken off, so something has been sort of pointing upwards. So in my opinion, and Steve Salisbury had a look at it as well, and he agreed, it's probably not a dinosaur bone, it's probably a scapula from a sea turtle, which would be a more likely find in a marine environment. Because I think we have 2 or 3 mosasaur vertebrae, and to have the same amount of mosasaur material as you have theropod dinosaurs to start with, apart from the fact it's not hollow, it's sort of unlikely. This is a view of Cretaceous outcrops near Calgary. And this bit here is called the Wendalia Sandstone member of the Mesozoic Shale. It's an Aptian unit, contains ammonites, and Ken has been very helpful in dating this particular section. So you find fossil wood that's been bored by shipworms, and bones of marine reptiles. But John Long, he found, that was in 1993, he found these 3 bones lying together, and he put them together, and together with Arthur Cruikshank, they described them as the first record of a Cretaceous theropod, because that came up before the Gingin bone was discovered. And I had a look at them, and I thought that the surfaces here where you glued them, it didn't quite look like they fitted. So I actually put the whole lot in acetone, dissolved the glue, and lo and behold, it turns out that this piece here actually sat over here. So when I reassembled it, it suddenly looks very much like, it was regarded as a caudal vertebra, tail vertebra of a theropod. It looks very much like a cervical vertebra of an elasmosaur. This is an elasmosaur vertebra that was found a little bit higher up in the stratigraphy, and the bone texture is identical. Every surface that you can still examine is identical. So in my opinion, it's not a tail vertebra from a theropod, but a neck vertebra from a sauropod. Most of my work I do up in Calgary, I take big bulk samples and look for sharks. And when I took a sample from this unit here, which is middle or upper Cenomanian, it's the uppermost part of the...
8 minutes.
I'm just about done in 30 seconds. So I take bulk samples and I go through it, and most of it is shark's teeth. But a few months ago, more like a year ago, I found a tooth that didn't resemble anything that I'd seen previously. It wasn't a shark's tooth, it wasn't a bony fish tooth, but it did strongly resemble teeth of diving birds called Hesperornis. This is one from North America, and this is the specimen from the Gila siltstone. So it looks like there's a strong possibility that that might be the 4th dinosaur find, being an alien dinosaur from Western Australia. And if I had a little bit more time, I would have shown you a 3D simulation of that tooth. We would spin it around, but I don't think so. So as it looks like now, we only have 2, one definite and one probable dinosaur find from the Cretaceous of Western Australia, and both are probably from the Cenomanian stage. But we are looking for, I took a bigger sample of this, trying to find more where you still have the root preserved, which was demonstrate a thicker tooth sort of structure, root structure. And that was it.